Good morning students, I am Vetri Chelvi from Vetri and Vetri Neet Chemistry. Before going to the class, if the viewer is new to my channel, please subscribe Vetri and Vetri Neet Chemistry. So far I have uploaded 92 videos, each containing high content of aims and NEET questions. Please utilize properly. Thank you subscriber. Now I am moving to the topic. In the given reaction, benzene is there, another one compound cyclohexene is there, in presence of HF, here 0 degree, what is the product? This is All India NEET 2016. It seems to be only the Fridel-Crafts alkylation reaction, but the students are not familiar with this reagent, so their knowledge is, what is it called as a Fridel-Crafts? Your knowledge is Fridel-Crafts reaction. Okay, now here, what is the reaction? This is the knowledge. Okay, what is the Fridel-Crafts reaction? Next knowledge is electrophilic substitution reaction. So the first step is formation of electrophile. So this reagent, that is called as a cyclohexene. Here, in presence of HF, that is your hydrogen fluoride. The first step is the addition of your hydrogen, that is H plus. What we are getting, or I can say as the formation of electrophile, or we can call it as a carbocation. So the bond breakage takes place, or I can say the addition takes place, and here hydrogen added with the rich one. So both are the same, of course. So one corner hydrogen is added, breaking take place like this. Let us see the breaking here. One corner hydrogen is there. For example, the bond is moving here, means there you are having the negative charge. So this carbon having positive charge. To the negative charge, your H plus electrophile is come and attack. So now you are having the formation of carbocation on this carbon atom. So it is only the ordinary electrophilic formation reaction. Since the reagent is very active, you need not require any other halogen carrier. That is the hidden knowledge is here. Okay, then once the electrophile is ready, means second step is electrophile attack of the electrophile on the benzene ring. Okay, now it is ordinary Fridel-Crafts reaction. So what is your Fridel-Crafts? This electrophile attack on, this is the electrophile attack on the benzene ring. Okay, now in the benzene ring, now pi electron shifting is there. So here you are having minus. So this place you are having positive charge. So this electrophile with the positive is attack on this carbon. So now structure is benzene ring, and here there is the bond is there. Here on this carbon atom, write down it is positive charge, and here on the minus, this carbon minus, there you are give one attachment of the benzene. Okay, that is your heat. This is called as a electrophile, which is coming with the positive charge. Now this is the attack of the electrophile on the benzene ring. So now this is the intermediate is formed. Okay, now this one you can call it as a arenium ion. Arene with the positive charge is called as a arenium ion is ready. Now what happened to this? Now we have to go for it. What happened to this corner is, already this place you are having one hydrogen. Now see the valence of carbon is 1, 2, 3 and positive charge is there. So now the hybridization of this carbon is 3 sigma bond. 3 sigma bond. Okay, and here it is. So 3 sigma bond means what is the hybridization? sp2. Okay, so what is happening? This hydrogen, now to get the aromaticity, remove from there, and the bond, this should be removed, and the bond is moving there to get the, what is it called as the its own configuration. So removal of the, what is it called, the hydrogen takes place, or bond shifting is takes place like this. So now the product is ready. So now refer with your product. Benzene ring with another one is called as a cyclohexane ring. Here it is your benzene ring with the cyclohexane. So this is your option. Okay, now I am repeating, children. Simple, it is Fridel-Crafts reaction. Since it is your highly active, fluorine is work at the, even at the door. HF is a very strong acid. So even in the, what is it called, 0 degrees centigrade, it works as a very active, of course. Okay, so this is the formation of electrophile, this is the attack of the electrophile, and this is the shifting of the hydrogen to form the more stable your aromatic compound. With that, we are moving to the next question. Okay, what is the next question? Which of the following compound will not undergo the Fridel-Crafts reaction easily? Just now only we have completed the Fridel-Crafts reaction. I will give the general reaction of Fridel-Crafts. Point number 1. Whenever Fridel-Crafts is there, the reactants, compulsory reactants are this is benzene with any other reactant in presence of anhydrous aluminum chloride with halogen carrier. Okay, like this is your halogen carrier. So what is happening is this one, any X or Y going to attack and you are going to get the product like this. This is the Fridel-Crafts reaction concept. Okay, the compound will come as a, what is it called, a electrophilic substitution reaction. Okay, electrophile means it is the positive charge should come and attack on the ring, meant the ring should having the rich in that is called rich in negative charge. It should be rich in negative, then only it can attract the positive. Okay, now let us see the structure of your cumene. Cumene structure we are having in the preparation of your phenol. This is your cumene structure. So, knowledge of structure is important. So, here this one is increasing the electron density towards here. So, it is favoring the Fridel-Crafts. Let us go to the xylene structure. What is xylene is, you are having methyl group on adjacent carbon atom or alternative carbon atom or para. This is for information. I am giving meta. So ortho, para, meta, whatever may be, this is, they are increasing the electron density. So it is also favoring the Fridel-Crafts. Coming to the nitrobenzene, we know what is nitrobenzene. And what about this nitro group is the electron withdrawing group. So it pull out the electron towards itself. So here electron density is decreases. What we want is rich in electron. What it doing is decreasing electron. So nitrobenzene not supporting the Fridel-Crafts reaction is the answer. Let us go and see what is happening in the toluene is. We know what is toluene is one methyl group. What is the nature of a methyl group is electron plus I. Electron density increases, so it is also favoring. So for this what you require is knowledge. Now structure of this. So your answer is nitrobenzene, which is not favoring Fridel-Crafts because it is electron withdrawing group. Question is very simple. Neet 2013. Okay, now let us go to the next question. This is Neet 2014. What products are formed when the following compound is treated with bromine in the presence of ferric bromide? So, given compound is the reaction is given is the electrophilic bromination. Okay, now let us write the reaction. We know today topic everything is based on the electrophilic, what is it called? So, here it is called as a substitution reaction. So, today's main knowledge is electrophilic substitution. Now, let us take your given compound. What is the given compound is the methyl group on the alternate. This is meta position. With that, what you are using is when there is bromine in presence of ferric bromide. Okay, what is this is giving the formation of Br plus. You know the mechanism. This is nothing but here, what is it called? Fridel-Crafts reaction, halogenation. Okay, now let us do this. Here it is electrophilic substitution of the halogenation take place. Knowledge is electrophilic substitution of halogenation. So for the formation of electrophile like Fridel-Crafts. Okay. It is like Fridel-Crafts. Okay. So this is ready. This is labeled as electrophile. There is one mechanism is there. There is other knowledge. Today you need not worry. Now just let us worry about the formation of bromine. Now let us see the substituent on the ring. This is deciding the position of the incoming group. So what are the positions of favoring is, for this is, I am going to give, for this is ortho position, this is your ortho position, and this is your para position. So for this both ortho para. For this methyl group, both ortho para. Why I am specific about ortho and para mean methyl group is ortho and para directing. So because of that, it is enrich the electron on this corner. So among this now, all the three are having probability of getting the electron. So which is favorable, which is not favorable, we are going to see. Now let me write one by one. Now first I am going to give the structure of, let me give for A position BR. Next I am going to give the structure of your B position BR. Next going to give the structure of your C position BR. Let us see one by one. Here it is both bulky group. Both bulky group. Okay, here BR is ortho to this, para to this. So this structure is favor. Next one, same reason. Ortho to this, para to this. So this is also favor. What happened to this? For this is ortho, this is also ortho. Apart from that, we know methyl group or both groups are bulky, sterified. They are more occupy the space. This is bromide also bigger. So because of the steric, this is not favor because of the steric hindrance or steric effect. It is fast but it not stabilized. So your position is A and B only. C is there means it is not possible. Let us see one by one option. Let us see first one is okay, but this is your or this is steric place not favor. Let us see here. This place is favor and here also favor. As I said, this is our A place. This is our B place. So this is favor. So our option is this is. Now let us come here. This one you can see here. This is favor. What about this is? This one you can see. It is meta for the both. This is meta which is not at all possible in this category. So this is not favoring. So this option is not correct. In this place, this is okay, but this is because of stability not stable. So like that you can eliminate and get the answer. So need not worry, do everything. Just to keep it in the mind. This is which is not favorable. First identify, then go and see, eliminate. This is at the middle, not favor. This is meta, not favor. Here again at the middle, not favor. Without writing, by a glance, by practice, we can select the answer. Thank you, children.